You know that feeling of dread, right? You
Yeah.
walk into a major meeting, plug your sleek new 4K laptop into the room's secondary display, and suddenly your crisp presentation looks like a blurry, stretched-out mess from 1998.
Oh, yeah, totally. It's the classic headache of hardware incompatibility.
Exactly. Okay, let's unpack this. The mission of this deep dive is to translate some pretty dense AV spec sheets
Uh-huh.
into a practical understanding of how commercial-grade video management actually works behind the scenes.
Right, and to really understand how this works, we're looking at a specific piece of hardware today from Smart-AVI. It's a high-end 4K converter and scaler, but it's important to set the stage here because this isn't some cheap $10 plastic adapter you just grab at the checkout aisle.
Right, right.
At $299, this is really built to act as a highly sophisticated traffic controller for your video signals.
A traffic controller. I like that. And as a traffic controller, its primary superpower is routing one single signal to two very different destinations simultaneously. I mean, it's a 1x2 splitter, right?
Yep.
One HDMI source coming in, two going out.
Yep, that's the basic setup.
But the standout feature is on output port 2. It has an integrated video scaling engine that can actually scale the video up or down from 720p all the way to full 4K resolution at 60 hertz.
Exactly.
It's kind of like, well, imagine giving a speech. You hand your original English script directly to the person on your left. That's your modern 4K screen.
Yeah.
Meanwhile, you have a dedicated translator working furiously in the background to just whisper Spanish to the person on your right, and that's your older 720p screen.
That is exactly how the architecture is set up. It's doing this live translation to ensure the second display gets the exact format it needs without interrupting the first one at all.
But wait, if it's heavily altering the signal for port 2, like scaling millions of pixels up and down on the fly, doesn't that inherently degrade the original picture's quality?
Yeah.
Or, I don't know, introduce lag into the whole system?
You'd think so, yeah. What's fascinating here is how it actually tackles that processing bottleneck. Because you'd normally be right. Legacy scalers definitely introduced noticeable lag.
Oh, for sure. Sometimes they were unusable.
Right. But this device avoids that by physically separating the signal pathways internally. Port 1 is basically a direct pass-through, zero processing.
Oh, wow.
Yeah, so it maintains full 4K at 60 hertz, complete with high dynamic range and a 4.4.4 color space.
Meaning it keeps all the original color data completely uncompressed.
Precisely. All the really complex computational math happens on an isolated chip dedicated strictly to port 2.
That's wild. So neither display is forced to downgrade its quality to match the other. Well, here's where it gets really interesting. You'd think that splitting and translating all this data in real time, completely independently, would require a massive server box with a giant cooling fan.
Yeah, you'd expect a beast of a machine.
Right. But look at the physical footprint. The chassis is only 5.63 inches wide and weighs less than a pound.
It's tiny.
Less than a pound.
Yeah.
Yet the specs are massive. An 18 gigabit per second maximum data rate and a 600 megahertz pixel clock, which basically dictates how insanely fast it can draw pixels on the screen.
If we connect this to the bigger picture, that immense 18 gigabit bandwidth pipeline is exactly WHY. It achieves things like HDMI 2.0 and HDCP 2.2 compliance without choking.
Okay, and HDCP 2.2, that's the digital copy protection standard, right? Like the handshake that causes your screen to just go completely black if the devices fail to authenticate.
That's the one. It requires a tremendous amount of processing overhead to constantly push high bandwidth video, audio, and those really dense copy protection protocols.
Right.
It also has independent switches for EDID, which is essentially the initial handshake where the monitor tells the source exactly what resolution to send.
Oh, gotcha.
So you have all this complex negotiation plus routing audio out through dedicated Toslink and 3.5 millimeter jacks, all running through a metal box lighter than a paperback book.
So what does this all mean for you, the listener? Well, it means that in a professional environment, you don't have to settle for the lowest common denominator when you're mixing old and new screens. You aren't, punishing your modern hardware just because there's a legacy projector sitting in the room.
Right, it completely separates the problem. You manage the older display locally without touching your primary signal.
It totally cures that blurry 1998 presentation headache.
Yeah.
But it does leave me with a final thought for you to ponder.
Oh, what's that?
Well, as our screens themselves become smarter and internal processing power just gets cheaper by the minute, will external traffic cop hardware like this remain the essential backbone of our AV setups? Or will the displays of the future eventually become so advanced that they just do all this complex translation themselves?